It's Mrs. Mafucci again, and we're going to be looking at redox reactions. Redox reactions is one of the most difficult topics in high school chemistry. So I want to do this little review for you so you can watch this video and take good notes. The first thing I want you to know is that redox reactions are reactions in which there is a transfer of electrons between the reactants. That means one of the reactants is going to lose electrons while the other reactant is going to gain electrons. Now let's consider some important things again. Oxidation-reduction reactions involve the transfer of electrons. We abbreviate oxidation-reduction as redox reactions. Now, oxidation is defined as the loss of electrons. When something loses electrons, we say that that substance is being oxidized. When something loses electrons, it becomes more positive. The oxidation number becomes more positive. Now, the opposite of oxidation is reduction. Reduction is the gain of electrons. When something gains electrons, we say that that substance is being reduced. Now, when something gains electrons, its oxidation number becomes less positive. Now, I put a little picture down there of Mr. Lion, and he says, Leo the lion says, grr. What does this have to do with redox reactions? Well, this is something I actually learned when I was in high school chemistry. Leo, that's the lion. Leo, loss of electrons is oxidation. Grr, gain of electrons is reduction. So you're going to want to be able to identify reactions as being either oxidation or reduction. So let's consider the following examples. When magnesium changes to Mg2+, is that gaining electrons or is it losing electrons? To go from 0 to +2 on the right, isn't that losing electrons? And how many electrons are being lost? If you said 2 electrons, you'd be correct. Now let's consider sulfur becoming the sulfide ion, S0, going to S2 negative. Hopefully you would recognize that the sulfur must be gaining electrons in order to change into an ion with a negative charge. Sulfur has to gain 2 electrons in this reaction. In this example, the chromium 3+ ion is changing into the Cr atom. Now, how does Cr3+ change into Cr0? Doesn't the Cr3+ have to gain electrons? This would be a reduction reaction, and actually, the Cr3+ would have to be gaining 3 electrons. In the next example, P3 negative, that's the phosphide ion. When it changes just into phosphorus atom, that 3 negative has to become more positive. That means the phosphide ion is losing electrons. This is oxidation, and it is losing 3 electrons. Now in this example, we have chlorine gas, Cl2, no charge. Remember, the oxidation number of a free element is 0. I don't have to write the 0. We just know it. Now, the chlorine gas, Cl0, is changing into the chloride ion, chlorine with a -1 charge. To go from 0 to -1, isn't that gaining electrons? That means this is a reduction reaction. Now, do you see the 2 in there? See how there are 2 chlorides and then there are 2 chlorines? Each chlorine atom is going from 0 to -1. That means each one is gaining 1 electron. But when we put a 2 in there, that means we have 2 chlorines doing that. And so that means there are 2 electrons being gained. In the last example, we have two hydrogen ions, two H plus ions, gaining two electrons to become hydrogen gas. This is also an example of a reduction reaction. Remember, oxidation is the loss of electrons, reduction is the gain of electrons. Now, we want to know how to write half reactions. Redox reactions can be divided up into two separate half reactions. And what that means is that there's an oxidation half reaction and there's a reduction half reaction. So let's think about this example right here. Mg going to Mg2 plus. On which side would I put the electrons to write the half reaction? Hopefully you would put the two electrons on the right side of the equation. Doesn't it make sense that the magnesium atom is losing two electrons to also form the magnesium 2 plus ion? In other words, the two electrons and the magnesium ion are both products. Also, remember what I told you in class? That in redox reactions, the charge has got to be equal on both sides of the arrow. What does that mean? If you look on the left side, magnesium, 0, no charge. On the right side, you have Mg2 plus and the two negative electrons. When you add those together, don't you get 0? So this is written correctly. If you had put the two electrons on the other side, it would not have balanced correctly. Let's look at our next example. To go from sulfur to the sulfide ion. We saw before that didn't the sulfur have to gain two electrons? When something gains two electrons, we put the electrons on the left side of the arrow. Sulfur plus two electrons goes to the sulfide ion. Notice the charge on the left side of the arrow. Isn't it -2? Look on the charge on the right side of the arrow. Isn't that also -2? You know that you have put your electrons on the correct side of the equation. In oxidation, the electrons go on the right side. In reduction, the electrons go on the left side of the arrow. Look at this one. Can you predict which side you're going to put the electrons on and how many electrons? Well, we already determined that chromium 3 plus going to Cr0 is a reduction reaction. That means the chromium is gaining 3 electrons. Remember, when something gains electrons, when it's being reduced, we put those electrons on the left side of the arrow. Let's consider the next example. Phosphorus with a 3 negative charge, the phosphide ion becoming phosphorus atom. To go from 3 negative to 0. In effect, isn't it becoming more positive? That means this is an oxidation half reaction. It's losing 3 electrons. In oxidation half reactions, we put the electrons on the right side of the arrow. That means it's going to look like this. Notice that the charge balances out. We have a total charge of 3 negative on the left side of the arrow, and we have a charge of -3 on the right side of the arrow. If you had put those 3 electrons on the left side, we would have had a charge of -6 on the left and 0 on the right. That would not have been correct. Now here's a tricky one. Chlorine gas, a free element, 0, going to 2 chloride ions. Well, you know it's going from 0 to -1. It's gaining 1 electron. But since we have 2 chlorines participating in this reaction, we're going to have to add 2 total electrons to give us this reduction half reaction. Let's do the same thing with our hydrogen ion, gaining the 2 electrons to become hydrogen gas. Remember, in oxidation, we put the electrons on the right side of the arrow. They're a product. When electrons are lost, they're a product. In reduction, they're being added to the reactant. That means in reduction, the electrons are being added to the left side of the arrow. Now, let's consider this example. The reaction between sodium metal and chlorine gas. Do you notice in the equation, sodium is all by itself? It's free, it's uncombined. That means it has an oxidation number of 0. But in the compound, doesn't sodium have a charge of +1? If you look on your periodic tables, you'll see that the only oxidation number sodium can have is +1. Sodium has lost an electron. Therefore, the sodium metal is being oxidized in this equation. And right here is the half reaction showing the sodium metal becoming the sodium ion, and the 1 electron is being lost. But remember, there's another substance in this equation. There's the chlorine. I bet the chlorine is going to take that electron. So let's now consider the chlorine. Chlorine is by itself on the left side of the equation. It's a free, uncombined element with a 0 charge. But Cl in the compound, sodium chloride, has a charge of -1. That means the chlorine has gained electrons. Therefore, the chlorine is being reduced. Now, when we write the half reaction, look at how we write it. We write chlorine gas with a charge of 0 is going to gain 2 electrons to become the 2 chloride ions present in sodium chloride. This is a reduction half reaction. It's important for you to remember that even though we write oxidation and reduction half reactions, they occur at the same time. If there's an oxidation reaction, there also has to be a reduction reaction. The next thing that's so important for you to realize is that the number of electrons lost must be equal to the number of electrons gained. That's going to be important when we look at balancing redox reactions. The element that loses electrons is referred to as the reducing agent. And the element that gains electrons is referred to as the oxidizing agent. So whatever is being oxidized is losing electrons and giving them to something else, causing that something else to be reduced. That's why it's the reducing agent. Now, the element that gains electrons is being reduced. It's taking away electrons from something else. That means it's causing something else to be oxidized. It is the oxidizing agent.